Hi viewers, this is Sri Ramulu. So today's topic is a insulator, semiconductor and a conductor. Insulator, semiconductors and conductors. So first, what are the insulator or what is insulator? See here, a substance which do not allow the passage of current. Passage means passing. Passes of current through them are called insulators, right? Insulator means which cannot allow the electricity. Okay, electricity means current. For example, so what are the insulators? Glass, wood, plastic. So I have written only three things. There are the many number of insulators are there. So these are the few example. Forbidden band is very wide. What is the forbidden band? Already explained in band theory of solids. Okay, so please watch that video. Due to this electron jump cannot jump from valence band to conduction band. So because of widening means very large gap between valency band and conduction bands. So that is why electron cannot easily jump from valency band to conduction band in insulator. The diagram is also given below. In case materials like glass, the valency band is completely filled at a 0 Kelvin. 0 Kelvin is a very lower temperature, and the energy gap between the valency band and the conduction band is of the order of 10 electron volts. 10 electron volts, right? That is the energy gap or energy forbidden gap for the insulators. Even in the presence of high electric field, the electrons do not move from valency band to conduction band, right? In the high, when if even though if you apply a high electric field, then electrons cannot jump from valency band to conduction band. When very high energy is supplied, very much high energy is supplied to the insulators, then what happens? See, supplied, an electron may be able to jump across the forbidden gap. Maybe, so we cannot say exactly, maybe jump to the across the forbidden gap. In case increase in temperature enables some electrons to go to the conduction band, right? So when we increase the temperature, then what happens? Some electrons may go to the conduction band, where from valency band. Certain materials which are insulator at room temperature and becomes conductor at high temperature. There are the few materials are there. So they are what? They are insulator at room temperature and become conductor at what temperature? At higher temperature. Next, resistivity of the insulator is of the order of 10 to the power 7 ohm meter. So resistivity is how much? It is very very large resistivity for the insulator. That is how much? That is in terms of 10 to the power 7 ohm meter. Now see that there is a diagram also for the RNC band and conduction band. So band energy increases in this direction. It is a valence band, it is a conduction band. So in insulator, conduction band is always empty, valence band is fully filled, then this gap is very much large, right? That gap is forbidden energy gap. And the next, semiconductor. In semiconductors, the forbidden band is very small. So comparing to, so it is very small means not too much small. It's comparing to the insulator small. Germanium, silicon are the examples of semiconductor. So we know the fourth group elements except carbon are the semiconductors mostly, but most important semiconductors from the periodic table, germanium and silicon. In germanium, forbidden band is of the order of 0.7 electron volts. See, this gap is how much? 0.72 electron volts for the germanium. For silicon, while in case of silicon, forbidden band is of the order of 1.12 electron volts. So for germanium, this value is low, and for the silicon, forbidden gap is more. Actually, a semiconductor material is one whose electrical properties lies between insulator and good conductor. See, it is a definition of the in semiconductor. A semiconductor material one is one whose electrical property lies between insulator and conductor, good conductor. So that is called a semiconductor. At a 0 Kelvin, there are no electrons in conduction band and the valency band is completely filled. So when there are no any electrons in the conduction band means a more total number of electrons may present in valency band only. When a small amount of energy is supplied, okay, the electron can easily jump from valency band to conduction band. Here in semiconductor, if you apply small amount of energy, then what happens? Electron starts jumping from valence band to conduction band. But in insulator, so more energy is required to move electron from valence band to conduction band. Why? Because there this gap is very much high. Okay, next, when temperature is increased, forbidden band is decreased so that some electrons are liberated into the conduction band. So when temperature is increased, what happens? This gap starts decreasing. Then there is a chance to move the more number of electrons from valence band to conduction band. Then what happens? When this gap is completely minimized at a higher temperature, then this device can act as a conductor. It easily acts as a conductor. And next, third, that is the last one, conductor. In case of conductor, there is no forbidden band. See here, we have a certain forbidden band here. Okay, that is a small comparing to the that question, comparing to the insulator. But here, conductor forbidden gap is overlapped. See, it is complete overlap. This region is completely overlapped. Now see, in case of conductors, there is no forbidden band and a valency band. Okay, so in case of conductor, there is no forbidden band and a valency band and a conduction band overlap each other here. So these two bands overlap each other, so no gap present between them. Here plenty of free electrons are available for electric conduction. For electricity, for producing electricity, plenty means large number of free electrons are available. Free electrons means which cannot under any influence of nucleus. Next, the electrons from valency band freely enter into the conduction band. Electrons from valency band freely enters into the conduction band. So whatever electron present in valency band, they also present in conduction band. Why? Because there is no gap between the valency band and conduction band. Next, the most important point in conductors is that due to the absence of forbidden band, so due to the absence means that there is no forbidden band. Because of no forbidden band, what happens here? Band, there is no structure to establish hole. So that means holes cannot present in conductor. That is the meaning of this. The total current in conduction is simply flow of electrons only. Total current in conduction is because of flow of electrons only. So these are the three important points and many times asked in the examination. So like write about insulator, semiconductor and a conductor, or write a difference between insulator, semiconductor and conductor. Okay, so for difference or whatever things ask about these two things, three things, then simply write these uh, three topics, small topics, then you can get easily marks. Okay friends, thank you. Don't forget watching this video till the